brain behind Baltic Lab.
Hi, Brian.
Sebastian, how are you doing?
Pretty good. Glad to be here again.
Yeah, it's good to see you again. I think it's been over a year since we last chatted. So just for our audience, Sebastian is a long-time electro contributor and one of the most inventive minds in RF and SDR experimentation that I know. So if you've watched his YouTube channel, you know he's not afraid to get hands-on with everything from satellite hacks to high voltage audio gear. So we're catching up on what he's been building since his last visit, and believe me, it's a lot. But before we go to that, let me bring up the giveaway, as I always do. We love to share cool tech, and today we've got a giveaway running during the show. One lucky viewer will win the Raspberry Pi 5 RTL SDR V4 bundle, which Sebastian has there with him. It includes the dongle, a dipole antenna kit, and the book Raspberry Pi 5 for radio amateurs. So just keep watching. We'll reveal a code word later that you can drop into the entry form, and then put it in there, and good luck. Now, before we get on with Sebastian, I want to tell you about our sponsor, Studium Travel. Studium Travel has more than 15 years of experience in organizing trips that focus on learning and experiencing. In cooperation with Elector, Studium Travel is organizing a trip to Taiwan in September. During this inspiring trip, they will take you to meet experts and leading companies, and you will explore the latest innovations. This is a unique opportunity to expand your knowledge, network, and gain inspiration. So read more about the trip at electormagazine.com/Taiwan. Now, let's get into it. Sebastian, welcome back to the show once again. And what have you been up to since the last time we spoke?
So many things. I think the most recent thing that has nothing to do with RF is my shelf with individually lit LEDs. There's 50 LEDs under each one of them, controlled by an ESP, which is hiding under here. I think this is just a much better background. But in regards of RF, I think this wasn't published yet before when I was on last. This right here, I don't know how well it shows up. It does. This is a spark gap transmitter. Needs about 20 to 30,000 volts. And this spark gap, when it arcs over, does energize this LC parallel circuit and generates an RF signal around 13 megahertz. This was pretty fun and challenging, and used to be the first way of communication. And I just had to recreate it. They're illegal to use, so I can't recommend anyone using them to get on the air, but they're certainly interesting to see how they work.
Well, I did buy something just for the fun of it. I haven't even opened the package. It apparently converts 3 to 5 volts to 400,000 volts. So have you been on the air illegally? I guess you couldn't tell us that on the show, but it looks like a lot of fun. Is it dangerous?
Well, I can tell you that I haven't been on the air legally, because as we've just established, it is illegal.
Yeah.
The problem with the signal is it's very broadband. We all know this. If we flip a light switch on and off and we have the radio on, we usually hear a little click. And this is essentially what this does. And possibly in some parallel universe, someone might have tried that recently. And it is quite fun, because you can pick it up on just about any frequency, even a few hundred meters down the road, especially if you have a shortwave receiver with an inbuilt ferrite antenna. It is pretty cool. And just the 20, 30,000 volts alone are pretty cool.
Yeah. And I'm just looking at some of the comments coming in from all over the world. Frank de Hert is first. And we've got the UK, we've got Egypt, we've got France, we've got upstate New York and North Carolina. So everyone in the chat room, Sebastian, as always, will have a lot of interesting things to say. And if you've got any questions to bring to that, please drop them in the chat.
Yes, do that.
Spanish comment. Hola.
Hola, Manuel.
Nice. So now, Sebastian, you've got the RTL SDR kit, and it's a good budget option, right? You've had a lot of fun with that.
It is. Actually, I posted 2 videos with that kit, exactly the way it is in the giveaway, no modifications whatsoever, for weather satellite reception. Some people may know, if not, you'll learn about it now. There are some NOAA weather satellites which broadcast an analog frequency shifted FSK, frequency shift keyed signal with very coarse weather images. But you can receive them anywhere in the world. All you need is that simple SDR dongle. And I used exactly this dipole antenna mount, something like this. This is called, obviously due to the shape, a V antenna. And I received, even on a very bad pass, it was a very low over the horizon pass of the satellite, an excellent weather image. And that was quite a bit of fun, just out of the kit, just like that. And the cool thing, yeah, there they are, second one, weather images from space. That one, exactly.
I'll just put up the preview with no sound. Looks very interesting.
And that's the picture quality without a preamplifier, without anything. And there's the setup, exactly. There's the V antenna, and there's exactly that RTL SDR that you can win during the giveaway today. There you go. There's the unboxing of the giveaway SDR kit. And that was pretty cool. No preamplifiers, no special filters, nothing. The antenna wasn't even pointed in the right direction. The satellite pass was horrible as far as inclination is concerned. And you saw the picture preview right there. It's amazing. Now, I should add that those pictures are very low resolution. I think if you skip ahead to the end where we can see the pictures, I can actually reference that. Yeah, they're a little bit further. Okay, just stop there. That's good. You can see that they are very, 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 very coarse. You can zoom in. You're not going to see any details. You can see big weather movements, and that's it. There are some other signals transmitted by Inmarsat satellites that you can also freely receive. They are in the L band, somewhere around 1.6 gigahertz, well, 1.5 to 1.6 gigahertz, which you can also receive out of the box if you have a proper antenna. That's the big if. There is two options. This tiny patch antenna with an integrated amplifier has an SMA connector where you feed power in. And right here is the patch. It's circular polarized. And this is sufficient to receive high quality weather. And I mean really high quality. I don't have any examples, else I'd show it. The other option is this giant thing. Which looks boring.
Looks like an antenna shotgun.
This is a helical antenna. This you can also build yourself. As a matter of fact, the guy I got this from built that. He sells it commercially, but this is 3D printed, and there's helix antenna calculators online, so you can just build your own. You can pick how many turns you want. The more turns, the more gain, obviously, but you can also, if you have an old satellite dish, use a small helical antenna and point it in the center of the dish. This sounds like my joints when I get out of bed in the morning. Here we go. Here's a smaller one. This is for 2.4 gigahertz. But this you could put in the feed point of a satellite dish, and this is for transmitting. It's a different frequency, but the same principle applies. And then you can get not only high-resolution weather images, but a lot of more stuff is happening on the Inmarsat satellites. Technically, here we come to the legality argument again, you could listen to phone conversations that are being transmitted through Inmarsat satellites. Very interesting, because people aboard of airplanes probably rarely think about how secure their communication is. You can definitely find all kinds of position information of aircraft, but also their service messages. When they type into their FMS that something failed and they need to arrange for maintenance to wait for them at the airport, you can intercept all these messages and read what's going on. Be careful what country you're in. I've seen, we've got many people from Europe, but also from the United States. In the United States, it's pretty much whatever you can listen to, you may. As long as there's no decryption involved, you can have as many scanners listen to the police. It's actually encouraged, and it's a good thing. Here in Europe, the situation is a little bit different, unfortunately.
Yeah, I would have thought that those kinds of communication would be secured and encrypted. So the satellites are geostationary?
No, they're not.
They're
I
not.
think the
So how do you...
Inmarsat is geostationary, the NOAAs are not. So you need a
Okay.
tracking software for that.
Oh,
If you
so
wanna be-
the antenna that you mentioned for picking up the weather signals, does it have to move at all?
No, because the main cone is, well, it depends. If you use the patch antenna, no. Just the general direction is good enough. If you have something more with a narrower beam width, like the helical antenna pointed inside a satellite dish or just directly at the sky, yes, you would have to know the position. But there's online websites, which I, of course, can't recall right now, that do the tracking for you. And I also don't remember the name, but I have something on my computer. Yeah, I don't remember. But there's online tools where you can track all the non-geostationary satellites, like the NOAA satellites.
Yeah, and I remember we talked about Ku-band LNBs.
Yes.
I guess those are vertically polarized, not circular. And now you've got some nice, I like your shotgun antennas, or they look like shotguns before you take them out the plastic. That's something I'd like to try. Never done weather satellites before. I've played with GPS, which of course is also low Earth orbit, not geostationary. And the Inmarsat that you mentioned, that's obviously geostationary, and that's airplanes are using that to transmit 36,000 kilometers up and down to talk to the ground.
Yes. First off, the position data, especially when they are over the big oceans, like over the Atlantic, over the radio, they actually talk to air traffic controllers on HF frequencies or the satellite ACARs, where they electronically send that information. And due to the nature of the satellites, it gets broadcast through the entire footprint of the satellite, so you can intercept that, which is especially interesting, not that I would know, during military movements. Like if you have a bunch of American C-17s flying over here. Now, I don't think the Americans mind if you intercept it, because again, in the United States, that is as fine as it can get. There, nobody would bat an eye. Then you get position information, you get service information. This can be interesting maintenance stuff. It can be engine performance data, or it could be somebody ordering catering for when they get down. It's quite interesting.
Yeah, and that reminds me, I used to subscribe to What Satellite magazine, and they actually talked about putting a live camera on a geostationary satellite just so you could have a channel on your TV to watch the Earth from the satellite's vantage points. Now, there were some concerns, but that was a long time ago. Do you know of any services that do anything like that?
No, not from the top of my head. No.
Okay, some people said, oh, terrorists could use it to track missiles or planes. And I was thinking, at that resolution, especially it wasn't HD those days, you can't even make out a city. How are you going to see a plane?
And even if it's not that the aircraft doesn't broadcast that out in its close proximity, it will have TCAS, the traffic collision avoidance system, as a extra layer of the ADS-B. The aircraft constantly broadcasts where it is and what it does. So in theory, that's possible. And actually, I was involved with something in the United States that had to do with that, and the FAA disregarded that as it doesn't matter because it would take nation-state type of skills to actually utilize that. The problem is not the technical tracking. It's not finding an attack point. If you have access to a missile, I think we're already a few steps further into the game. That's the big problem. Tracking, sure you can.
Yeah. Well, I would love to see a live high-resolution picture of Earth. I would put it on a separate screen permanently. The weather pictures are obviously much coarser, as you pointed out. But having worked on that project, what else have you done with the RTL SDR? This one or previous versions?
I've actually delved into the much lower end of frequencies. AM radio is mostly dead in Europe. I don't know of a single station that we have left in Europe. So it's starting to become interesting at night to go down to the very low frequency edges. And there's a few products that I have in the back. The SDR Play products are very good, at least one of them, the RSPDX, all the way to 9 kilohertz or something like that. And it's very sensitive down there. And it's very interesting to take it as a challenge to listen, for instance, Radio Caroline, which I think still transmits from a ship from the coastlines of UK. They started as a pirate station a long time ago, and now they are legal, but they still transmit from the ship that they formerly used to get away from the shoreline, to get out of the legal realm of the UK government. And that's what I've actually been delving into, because here's the challenge. The higher the wavelength, the longer the antenna, in theory. So obviously down there you need pretty big antennas, theoretically. There's ways around it, which I can talk about in a second, but that's really interesting. I don't know what the distance from here to Great Britain is, but it's quite a lot. And you can hear the effects of during, like right now, during the day where the sun shines, you're not gonna hear a thing except static. And the moment the sun is gone through the entire path, you can listen to it. That's very interesting at that point where the sun sets, where you hear that fading in and out. And along the same lines, and we had a talk about aircraft before, there's NDBs, non-directional beacons. They are somewhere around 300, 350 kilohertz. They transmit. They are back from the old days where they didn't have GPS and anything like that, but they're still operational all across Europe. And it's very interesting to see at what time of the day you can listen to some beacon in Spain just with a tiny antenna. And that's actually what I wanted to get at. In theory, of course, the antenna size depends on the wavelength. Down there in the 350 kilohertz range, this is extremely long. And there's some antennas like this. Of course, I forgot the name of it. It has a very high impedance amplifier, a JFET amplifier, and just this little tiny conductive plane. With that, you can listen from a few kilohertz to up to 30 megahertz.
Wow,
and
up to 30 megahertz.
Yes, and they're just getting around it by that high impedance input. There is a bias T that's sitting around here somewhere. It disappeared. But the cool thing is with the SDR Play products, and I'm pretty sure this RTL SDR that we're giving away as well, has an internal bias T. Theoretically, this should take 5 volts. The output from USB is 4.7 volts or something like that. It doesn't matter. I could sit this up right here in my office inside concrete walls, and I could listen to NDB stations from airports all around the world, or Radio Caroline in Great Britain. Pretty much the only one I tune in. Somebody asked if the BBC is still active on long wave. I don't know. I honestly don't know. If somebody in the chat would Google that and let us know, that would be very interesting. I just know that Mittelwelle, whatever that is in English, is pretty much gone.
Yeah. What is the frequency range? I know of AM radio. I know FM is 88 to 108.
600
megahertz.
Kilohertz to like 1.2 megahertz. I don't know what the legal boundaries are, but something around that.
Having just Googled that, I see there are still AM radio broadcasts here in South Africa going, according to Google. But I don't know where I would find an AM radio besides the RTL SDR. I have an older version. But to just pick up AM radio out of the box, I'd probably have to get into a car. Thank you, David, for that information. That BBC is on 198 kilohertz, but is being switched off on the 30th of June. Speaking of switching off, something from Abraham. He says that NOAA has announced the end of life of NOAA 15, 18, and 19 on June 16th, but they'll carry on working until there's some failure that forces them to automatic decommissioning. What would be the replacements in the future?
I doubt they will replace the old APT satellites because of their low resolution. They will probably just use the HRPT, the high quality signals, which makes sense. It's free. I know Europe has started a few satellites, of which I, of course, also forgot the name. But there are NOAA satellites with the HRPT signals, which are much finer in detail. And especially those mentioned there, 15, 18, and 19. They are probably older than I am. And there's no need to replace them because nobody really needs that low resolution images these days.
And Thomas Hutter also said earlier that illegal transmissions might be the most fun ones. So let me ask you about the spark gap transmitter. Why did you build it? Was it just a retro curiosity?
Yeah, it actually it started with nothing that had to do with the transmitter. It was a discussion in an EMC class about what has more spectral density, the spark inside a regular light switch or from lightning outside, like a lightning strike versus a light switch on the inside. And it turns out it's the light switch that has a much broader spectral bandwidth. And from there, I got into reading about spark gap transmitters, and I thought, let's just build one just for fun. There was another experiment associated with it, and that is the question. We can throw that in the chat before I continue talking about that and ask people, what is the breakdown voltage of air? Like, what do you know? What have you been taught? Because this is very interesting. You'll get different numbers. You get, usually on the internet, you also get people like, I had a 3 centimeter spark, so obviously this must be around 90,000 volts. And it's really not that obvious. That's the problem. There's different numbers. You get them between 10,000 and 30,000 volts per millimeter. But they vary. And the question is always like, what are you trying to do? Are you trying to force a spark, or are you trying to avoid a spark? And usually it's looked at from the point of, I'm trying to avoid a spark. And also it's not linear. If you double or triple your distance, the voltage doesn't double or triple. There is the air
Inverse
pressure.
square law?
Not even that. That's the problem. It's the Paschen's law is what it's called. I think in English it would be the law von Paschen or something like that. Paschen. And it looks very interesting, the curve, because as you can imagine, as the pressure lowers at first, it can spark over more easily until such a point where there isn't enough electrons that can be, yeah, there it is. There's the curve. And then we see that bend. It seems linear enough, but it really isn't. It's only thrown off because of that steep curve on the bottom left. And that curve happens that at some point there isn't enough electrons to be ionized to cause an avalanche breakthrough for that spark to start. That is what we see in a vacuum tube. It's much harder to cause an arc in there. Yeah, it depends on pressure, it depends on temperature, the distance. I don't think it's quite square. And yeah, that's extremely interesting. So that was the secondary experiment that I haven't filmed yet, but I have some. Would I find them? Yeah, hang on just a second.
So they, in this graph, have the characteristic curves for helium, neon, argon, hydrogen, and nitrogen. Would that be pretty much the same in normal air?
Would that be the same in what?
In normal air, because those are, they put 5 different gases on that characteristic graph.
The nitrogen would be the dominant one.
And I'm guessing, don't try this in pure oxygen.
The nitrogen would be the dominating one in air. And that's exactly what I experimented around with. Right here, you see this little acrylic tube, which has a gas connector right there and high voltage connectors here. There's this rather large spark gap and a much smaller one. Doesn't really show up that well on camera, does it? And then I have plenty of gases sitting around here. I have argon, I have neon, of course I have plenty of air, and I have CO2. And it's very interesting to experiment with that, because in argon, with just 10,000 volts, I can create an arc in this. 30,000 volts in air, maybe I should put them next to each other just for comparison. You know, that's just the distance, about triple the distance. And you can use this as a switch when it comes to really, really high voltages. When you want to discharge a capacitor bank, for instance, you can use that as a pressure control switch. You can pressurize this chamber so that the breakdown voltage would be above the charge voltage of the capacitors. Then through a valve, drain the air, and it would fire through. And once the channel is ionized, it's ionized, and it'll stay ionized until it's empty, pretty much.
Well, that's a good point made by Gordon. It would depend on the environmental conditions, including whether you've pressurized it or not. Some interesting stuff coming here from our radio people. BBC Radio 4 is transmitted on 198, but also carries phase modulation for time signals and was used to switch electrical meters. That's interesting. But the government wants to use wants us to all have smart meters, then the BBC will turn that off. And then Thomas Hütte again says, let's petition to keep BBC Radio 4 long wave alive.
Yeah, let's actually do that. While not many people listen to it anymore, I think especially, I don't want to get political, but I guess Europe, the politicians in Europe are somewhat certain that we are closer to a crisis than we ever have been. And I think especially in possible times of crisis, these stations were so important. Now, I understand that we don't need 20 AM radio stations. Nobody's going to listen anyway. But something like the BBC, keep that on the air. In a really bad situation, that would be the best source of information. And I think we should keep this on. And yes, many stations carry control signals. And of course, there are still time signals in that general frequency range. Well, they're a little bit lower. We use 77.5 kilohertz, I think, DCF 77. And the Brits have something different. I forgot where they are, 68, 66, something like that. It's also quite interesting to receive that at night.
Well, if we're going to talk political realm, the Trump administration has threatened to defund Voice of America and Radio Free Europe. Have you actually seen any on-the-ground technical, anything changed in that sphere? In terms of shortwave or AM? Not yet. Okay.
Not at all. The only thing that I could relate to that political issue named Trump is from Hollywood movies, we would assume that all military communication is encrypted. You'd be surprised, in reality, you'd be surprised how much of it isn't encrypted. 8.992 megahertz and 11.150 or 1150, I forgot, very interesting frequencies to listen to all around the day, anywhere in the world. It's officially the high-frequency global communication system. Officially belongs to the United States Air Force. In reality, all of NATO forces all around the world use that. The French use it a lot. Germans use it a lot. Ramstein Air Base would be on there a lot. Just trying to be careful. Of course, again, I wouldn't know any of that. But those are very interesting frequencies to listen to. All around the day, you have clear voice communication. Of course, there are also emergency action messages, which are, I think, 56 character numbers, which are also very interesting because when the US Air Force transmits them, there are various transmitters all around the world that transmit at the exact same time. So you hear an echo that's created just by the runtime around the world. But in European airspace right now, there's lots of AVAX airplanes that keep a good eye on our airspace. They all talk on there. They give position information, they do their radio checks, and it's extremely interesting that just with an analog receiver or the SDR dongle that you might win later and a small wire antenna, you can just listen to all that NATO communication and the US Air Force. It's very interesting.
Well, it's interesting that I've Googled it, of course, and I found this old forum for comments from 2009. And this person keyed into both 11175 and 8992 and got a good sampling of coding and callouts on the west coast of the US. And also says all I hear on 11175 is Andrews to all other stations. So I'm not sure what the legalities are, depending on the country, even in my own country, but it certainly is a very interesting topic to be eavesdropping on that.
Give me just a second. What audio have I shared? Well, you should still be here through feedback.
Yep, I'm hearing you. You may have to just hold on a second.
Yeah.
There is noise reduction automatically here. So I'll turn off the background noise reduction for a second so we can hear you properly. Go ahead. Wow. And what frequency is that?
That is 11175. He's even announcing that. And there on the Ramstein Air Base, there's more communication, but we're gonna spare that. It's very interesting. Of course, somebody sent that to me, but it is very interesting conversation. Because I think the pilots themselves forget sometimes that they're on open channels. You can even listen to hot phone patches. Of course, they're usually just maintenance phone patches. But even there, soldiers are human beings like anyone else, and they sometimes forget that there's something like classified information and that is not a channel for such classified information. So I've been told, at least.
Also, you've been told. I would then recommend to our audience to visit Baltic Lab. You will find more information on the RTL SDR kit over there. But while we're there, I'm going back to the giveaway, because we are giving away this bundle today. And as I said, halfway through the show, so now we're at the bottom of the hour, I would encourage you to go to the giveaway page. You see the URL there, but we'll drop it in the chat. And the code word is simply RTLSDR. And go ahead and enter. I'll bet we'll see a lot of interesting entrants coming in right now as we give away the keyword, as always happens. So thanks to everyone for entering. Let's get to some interesting radio facts coming in from the chat here.
Hang on.
Someone mentioned
Jan Willem, where did that antenna go? Yes, he said, I believe the high impedance antenna is called a mini whip antenna. Yes, exactly. That was the name I was looking for. They don't cost much on Amazon. They cost even less on AliExpress, and they cost even less than that if you just build it yourself. However, it might cost more frustration after you blew the first few JFETs, but it's also an interesting lesson. Yes, exactly that comment.
Yeah, so thanks for that, Jan. Said there was something about Polish radar. Yes, on 225 kilohertz, no plan to discontinue it. Yeah,
nice.
It could be important, as Sebastian was saying. And there's our code word. Thank you from Elector Studio for helping me with that.
Hang on just for a second. I gotta go sign up for this giveaway. I'm just kidding.
I believe you have one already, so don't get greedy.
Yeah, but 2 is better than 1.
True.
I actually have one of them on the roof. Yeah, maybe that's something we can get into. Let's give everyone some time to sign up. And I'm going to look something up in the background.
While you're doing that, Michael Walker says, Mi Amigo used to be the ship. I don't know if he means Radio Caroline.
Or he meant the pirate radio.
Okay.
I'm not sure. Maybe he can clarify.
Yes. Drop a comment there and let us know what you meant. So now, you always do great documentation. You have to. You're making videos. Do you prototype quickly and refine later, or are you a perfectionist from the start?
I wish I was. I usually make a plan, and it doesn't take long till I realize that that plan was complete garbage. Then I am too lazy to just replan and start doing. It is frustrating at times, but I've always found that it's just as valuable to find out all the ways that it doesn't work, because then later on you can be a wise guy. When somebody wants to try something, you can say, no, this doesn't work because of this and that. I think I've told the story before, and I'll circle back to your original question in a second. Do you remember those Cosmos electronic, what were they? Those electronic kits where there were a few LEDs, resistors, like probably 20 years ago. No, longer. I was a kid, where you could just build simple astable multi-vibrators and stuff like that. On the first page,
was it like a console with spring clips for the wires?
Yes,
yeah,
exactly. And on the first page, it said, never ever connect an LED directly to the battery. But it didn't say because it would damage it or anything like that. So I thought, why not? Did it. It blew up. The old LEDs, I think anyone that's old enough here knows that they actually, I wouldn't call it explode, but there's enough steam pressure in it that the head actually flies off. And I thought it was so much fun that I bought 100 more just to do the same thing, but I used 20 volts then directly from a high power supply. So back to your question, I think this is so important. All the things that fail, they may be frustrating, but you learn so much about what not to do. So I usually adjust then as I go. Now, sometimes this is really annoying when something is almost finished and you realize that it's not finished, it's finished. Could be finished, depending on where it's from. But yeah, you forgot the wrong voltage rating or power rating, and then you have to go back and redo everything. It's frustrating, but that's kind of how I do it all. Yeah, Cosmos, exactly. That's the guys I meant. So that's how
Cool.
I plan. And I'm very bad at documenting. I have to force myself to post videos. I have to force myself to write articles. Like the spark gap thing that I just showed you. That experiment has happened before the spark gap transmitter. I could have documented it, but you can't pay me to do it. Sometimes it's like, okay, this is done now, so I'm no longer interested. Now, when people know about it and kind of pester me about it, then yes, I will do it. But until that happens, I'm horrible at documenting.
Well, that would make me ask you how then you managed to run such a successful YouTube channel, because that requires scripting and editing and documenting.
You would think. No, there's no scripting involved whatsoever, none. Sometimes, though, a 10-minute video has 2 hours of footage, because I will just film while I'm doing it. I'll rant into the camera. I'll say the same things 20 times in different ways. Then later on, while editing, I realize, crap, said the wrong thing. Then I'll put on the same shirt, same background, same light, say the same thing again. So I could probably save a lot of time if I would just start scripting, but you can't get me to do it. It's always been that way. Same in university. I'll do the experiments, but no, I'm not going to do the preparation work and the lab report. Either somebody else does it, or I'm going to take the 0 points for it. I'm happy with that. I've learned what I need to learn.
Well, if you don't script it, you're going to have to sit through that 2 hours of video to edit stuff. And then, like you say, put the shirt on. A lot of people wouldn't do that. They would just put a correction in the text over the video. Nobody wants to go back to the camera during editing.
At least some pretend perfection needs to be there. What did the Americans always teach me? Fake it until you make it.
Yeah, exactly. Here's a question from Gordon. What software is available to track air traffic?
Gordon, perfect timing. Let me share my screen.
Let's get it up there. Yeah.
Hang on. I gotta actually do that. There. Share a screen. What do I want to share? I want to share that window. No
While you're
audio.
doing that, I just want to help Hugo here, who says, on the giveaway form, I get the message, the recapture field is required. That's this field down here. If you don't see it, it might be an ad blocker, so just take a look at your browser. Okay. Back to you, Sebastian. You're sharing your screen, and I'll add it to the stage.
Yes.
There we go.
So this is completely free. This is TAR 1090, which you can install directly on a Raspberry Pi if you have one sitting around. And it creates a web server. Theoretically, you see the URL up there is public, so technically anyone could access it, but it's password protected, so don't even try, but you could. And then you can, from your cell phone, from your laptop, wherever, you can just check this wherever you want to. I'm just not zooming out because then you'd see my location. I really don't want to share this in that context, because here's the legality argument again. Let's see, is there military on here? Yes, there actually is one. This is in the frame. There we go. We got a France military aircraft of some sort. Doesn't even say what it is, but it is quite interesting to see what all this, especially there was, what was the name of that exercise? The Air Defender exercise, which was over the northern part of Germany. There was a lot of interesting activity. Yeah, TAR 1090 is free, completely free. You can use it locally. You can, like me, share it. Speaking of sharing, let me see if I can find that on the next screen. If you've ever heard about Flight Radar, can I share this? No, I better don't. Flight Radar is a page where you can track any aircraft, well, except some military aircraft. Anyone can access it. Depending on your access level, it costs money or it doesn't. If you feed your own data from your Raspberry Pi into the Flight Radar system, you get a premium account for free. So you can even 3 weeks back track an aircraft if you want to. And that is extremely cool, because the Raspberry Pi end is exactly an SDR dongle just like that from the giveaway. They are sitting on the roof together with a special antenna. Hang on, do I have one here? Yes. Cheap as it gets from Amazon, actually, for 1090 megahertz. Then there's a homebrew circuit board with a SAW filter and a little preamplifier, just some mini circuits, MMIC, and it works extremely well. Let me see where my boundaries are. How big are the rings? Yeah, I don't want to show the location. I think they are 100, 150, yeah, 200 kilometers. So you see here at those locations, I'm peaking at 200 kilometers of range.
Okay.
Of course, this only applies to the aircraft that are really high up. If they are in ground proximity, I'm not going to be able to view that far.
Well, I'm looking at flight radar while you speak, and yeah, it works. So if you want a cellular option, okay, there we go. My screen is a bit bright, but yeah, flight radar works as well if you're on your phone. And you were saying if you feed your Raspberry Pi info into it, you get a premium account for free.
Correct.
It's very interesting.
It does that automatically, and if the question wanted something much more simple, like as in plug the SDR stick into your laptop and view it right on there, I think it's called Dump 1090. Let me see, since I have all that stuff installed somewhere. RTL 1090. There's Dump 1092. Let me see, an RTL 1090. It doesn't work. Let me Google RTL 1090. Yes, RTL 1090. Why ever my installed version doesn't work. RTL 1090 you can download for free. All you gotta do is stick the SDR dongle into your computer, and then you can immediately look at aircraft. The special thing about that is that you can also see Mode C codes. Now, small background for that. The data that you see here that has position, altitude, direction, all that stuff, that is ADS-B data that contains all that information. Originally, aircraft would just send a secondary radar response. The interrogating antenna would send a signal on 1030 megahertz, so 1.03 gigahertz. And the aircraft would respond with a challenge code. This is actually derived from World War II identification friend or foe system, although that was Mode A. And this Mode C has, aside from this identification number that the air traffic control assigns to the aircraft, also the altitude readout in 100 feet increments. And RTL 1090 can decode those. Why is that interesting? Because especially some military aircraft do not transmit this ADS-B data, which contains position and direction and intent, but you can see that they are there, and that is also quite interesting to see what they're doing. Like here where I live, there is GFD, which is a company that does target simulation for the Bundeswehr. So they will fly with Learjets into the airspace unannounced through routes that an adversary might take, and challenges the Bundeswehr to see how quickly they react and how they respond at all. And those, of course, fly ADS-B dark. They do not transmit their identification, but you can still see them in this Mode C, and RTL 1090 can do that. So I've been told.
Very interesting. There's a lot of interest in the spark gap transmitter in the chat room. Michael says he always thinks of the one Marconi used for transatlantic tests, and the circuit diagram is available online. Must have been an amazing time because the radio waves spectrum was very quiet back then.
Oh, yes. But it wasn't after the invention of the spark gap transmitter.
Yeah. How do spark gap transmitters differ from modern radio transmitters in terms of signal clarity? And that's from Jack.
Significantly. Hang on, I'll get into that in a second. I want to check the Marconi circuit drawing. Okay, it was already better than my version. Yes, I would recommend, Jack, watch the video that I posted on it, but I'll briefly go into it anyway. The thing is that a new transmitter has very high spectral purity. There is very few side tones. Ideally, I mean, of course, there are also garbage transmitters, and a spark gap transmitter transmits all over the place. And I mean, all over the place. There's huge bandwidth of a few megahertz, and the data contained is basically just, it's supposed to be a continuous signal. So theoretically zero bandwidth, but it has multiple megahertz of bandwidth. And then, let me not throw that. some design problems. For instance, here's the parallel LC tank circuit. This, of course, has some resonance frequency, but the moment, maybe I should talk about how this works in general. So this RC circuit, if you apply the high voltage here, this capacitor gets charged, just a regular RC charge curve. At some point, the breakthrough voltage is reached, the spark gap breaks down, and in an ideal world would only energize this LC parallel tank. In reality, the moment the spark gap fires, this capacitor is also in parallel with this entire circuit. Until the arcing stops, then it's just that capacitor and that inductor on their own. So there's actually two distinct peaks in the spectrum, which I've actually shown in the video. So in the video, there is a capture of the spectrum. There is some math as far as the Q factor and all kinds of other things. The other thing is that the tone isn't really continuous at all. Well, when the LC circuit gets energized, it's obviously as high as voltage is ever gonna get, and then it slowly decays. I don't know if Brian still has the video. Yes, perfect. Yes, there's the schematic, but if you go forward, I'll let you know when to stop, probably quite a bit forward.
What are you looking for?
More. The spectrum.
Okay. Spectrum analysis.
There.
Is that it?
No.
Not
No.
yet.
Well, let's stop there. That is the waveform that comes out of it. That is one cycle. On the right side is the theoretical, the way it's supposed to look like. On the left is the real one. So it's not even a continuous tone. There's always residual AM modulation because of this damped wave. It's, by the way, that's also the term used in the ITU documents that make that illegal. It's called a damped wave transmitter. Now, Brian, if you go forward a little bit, we should see a spectrum somewhere. More.
That one?
More. Yes, that is one. That is just the main peak. And you can see how extremely wide that is. Let's see what I have was. Yes. Yeah, there you go. See the second peak. And the lower peak happens from the two capacitors being in parallel. This is extremely wide. I'm trying to read what my scale was there, but yeah. So that much for the purity argument.
So did you try and alleviate that, which is a question from Dom?
Not
How
at
did
all.
you, if you did manage EMI and signal bandwidth? Okay, so it was just an experiment. No effort was made to keep it clean.
There was a brief challenge to do that, but then I decided, nah, it's just for demonstrative purposes. I'm not gonna improve spark gap transmitters. Yeah.
And from our always informed radio audience, Radio Caroline can be heard in some places in Great Britain on 648 kilohertz or via the web. Yeah, the web has taken some of the fun out. I used to have a...
Yeah, go ahead.
I used to have a 4.8 meter C-band dish, and it was like magic receiving something that originated in Russia and bounced around the world. Now that everything's on the web, it takes away some of that fun.
I sometimes use the Radio Caroline web stream just to ensure that I'm actually listening to Radio Caroline, but at nighttime I can actually receive it here in my office with an antenna outside the window. But yeah, it was kind of cool. And I've actually messaged them into the show once before, and they were quite amazed that I was listening from Germany at that time. It was kind of cool. I somewhere have the recording of that. I recorded them saying that I sent them an email. That was also kind of cool.
Awesome. So this software, somebody was asking in the chat where to get it, and no, it's not at that URL that you see at the top there. Where can you get that Raspberry Pi software, Sebastian?
There.
There we go. TAR 1090. Yeah, please do. And Jack says, thank you for explaining, Sebastian. So Sebastian will drop the URL in the chat, which is great, because I'd also like to have a look at that. I've got some spare Raspberry Pis.
I think I posted it. Did I? Yeah, I think.
Yes, I see it here from Baltic Lab. Baltic Lab. You do content in 2 languages, speaking of which. Isn't that really painful for you as well? You were talking about how you hate to plan and script and stuff, but you've got to do two languages.
It is, and what really gets me is now that it is redundant. Now I have auto dubbing on my large YouTube channel. I mean, it's only available for larger creators. And now I don't know what all the languages are: Spanish, English, German, and a lot of experimental languages, even Chinese, Japanese. So I listened to the dubs and they are not that bad, but I found you have to upload a closed captioning file. Now, luckily, and I've been praised for that before, for every single video that I've uploaded in the last 3 years, I have uploaded a very accurate closed captioning file, because there are hearing impaired that like to read, and my closed captions are spot on, because the automatic YouTube captions, well, we've all seen them.
Yeah, they don't always work that well. Sometimes I'm scrolling through YouTube Shorts or TikTok or something, and I see one of your videos in German. And I must say, I'm not a native German speaker, but you speak very clearly. In fact, once I asked if you had cloned your voice using software, but no, that's really Sebastian speaking. Except for now with the auto dub. When he speaks Spanish, probably not him. So you showed us a spectrum analyzer, and that's an obvious piece of test equipment that you would have to use, but what sort of other test equipment is essential in RF builds?
A network analyzer, a vector network analyzer. It doesn't have to be an expensive one. I'm just trying to figure out where I put mine. I have a cheap one somewhere. Yeah, I think it disappeared. It didn't want to participate today. It's a nano VNA. Where did it go? No, it's not participating. It's a nano VNA. I don't remember what version it is. They are fairly inexpensive, but a vector network analyzer is going to save your life in so many situations, where it's not going to save your life, but definitely preserve lots of your life, because you would otherwise lose it from stress level. I don't know what they cost these days, but Google will know.
It does sound expensive.
No. The nano
Gordon
VNA...
wants to... Sorry. Jumping on top of you.
Nano VNA around $100. There's different versions, and they are accurate enough for hobbyists, definitely.
Perhaps I'm thinking of the old days. In the 90s, a network analyzer would have been very expensive.
Oh yes.
Gordon wants to know what the schematic is of the RTL SDR. Is that easily available online? Well, I'm having to find out. I'm having a look, yeah.
Yes, apparently so.
It seems to be quite open. There we have the Electro magazine site if you want to read more. It's a whole blog about it.
Yes, okay, I didn't know that the schematic is online. Cool, now we know.
Great. Yeah, looking at these and looking at what you've done, I want to pull mine out, but I've got an older version. Is there a significant difference between the new V4 there and previous versions?
If it's really, 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 really old, you don't have the HF bands in it, because there was an addition later on. Back in the day, you needed an up converter for that. The sensitivity has improved significantly. I mean, just the background story, these SDR receivers started as common TV reception dongles, and nobody thought about using them for SDR. They were specifically for analog television, later on digital television, and that's what they were used for. And then some smart people discovered, hey, I can access the IQ data, so I can actually decode anything I want. So the very old ones are for 75 ohm systems, which is already mismatched to the common 50. However, for hobbyists, I always say it doesn't matter. Like 75 to 50 is an SWR of 1.5. Nobody cares on reception. They are a lot more deaf, because obviously television signals used to be quite strong, so they didn't have to be sensitive. Those are the primary differences. And I would, if we can, would love to use the last 5 minutes to actually talk about the different SDR options that there are. We've covered that most basic. With basic, I don't mean bad. This, what Brian has up there, that SDR receiver will get you started. It has one input, one SMA, goes directly into your computer, and that will get you started with anything. Now, as time progresses, you're also going to get continuously more lazy, obviously, and you might want something like this. This is the SDR Play RSPDX. It's a great device because it has 3 inputs. You have antenna connector A through C. They can be switched independently. There is a bias T included, so you can power, for instance, that mini whip antenna. And I think I wrote a review for a lecture for that RSPDX, and I put that mini whip antenna on there. And it was literally sitting on my desk while operating it, and I was listening to amateur radio operators in the 80-meter band. It also, and this was very important for me, has a reference frequency input. So if you have something like that Leo Botner that I have up there, it's a GPS locked, or technically a GNSS locked frequency standard. You can feed that into the RSPDX, and you're going to be spot on frequency, extremely spot on. Now, the problem with this is you have more antenna connectors, and this beast is extremely sensitive on very low frequencies, and it also has inbuilt filters. Usually VHF radio does get in the way sometimes, and DAB and DVB-T. So you can filter that out. There's notch filters. And yes, there's the review. But there's still a problem. Like, for instance, my office is in a concrete building. I have this USB connection for my computer, and I have the antenna connections here. Running 20, 30 meters of antenna cable is not good because of the attenuation. Running 20, 30 meters of USB cable isn't cool either. So while you could use a Raspberry and operate it remotely, there is a better option for that. And that is the empty box. The device is set up behind me. There is also from SDR Play this NRSP-ST. This is a networked. It's basically like the RSPDX that I just showed, but on a network. It has Wi-Fi, and you can also wire it in. 1 kilohertz through 2 gigahertz, like the other one. It's actually set up behind me. I just have this little antenna hooked up here, little V dipole, and here's the SDR Play. And I think my screen sharing is still active.
Yeah.
Let me see if it's connected. Yes.
Great.
So here we could listen to stuff now. And actually, I'm going to do that for the remainder of the stream. I'm going to post this link. This should be publicly shared. So you can actually, I think 10 of you can, and then it's going to say, I don't want to participate anymore. But there should be a queue if you go in it anyway. So give it a try. I can actually check on the normal thingy here. There I can see how many people are going to go in there in a second. One thing I want to mention, you can access it through the software that I have here, the SDR Connect, or through the browser. And that's the link that I sent. Oh, I see I got the browser still shared. So that's better. Here's the browser version, and the other thing doesn't show up because I have the window shared, not the screen. Well, doesn't matter. It looks exactly the same way. And also, let's make it more quiet, and let's check how many of you. Well, 2 of them. That's just me. So nobody has bothered checking into it yet, which is good for the network. It can be password protected, but you can share it with your friends, with your family, whoever wants to listen. You can operate it as a remote device using SDR Connect. And also, I've been told by SDR Play, there's going to be an app sometime in the future. There was no real deadline on it, but there will be an app, so you can just pull your cell phone out and operate this device remotely. But the coolest thing is you can put it somewhere on an antenna mast, put an antenna on there, like a mini whip for 9 kilohertz through 30 megahertz, and then a discone antenna. Only have a broken one here. A healthy one is on the roof. Something like this. Covers about 52 megahertz through 1.3 gigahertz. put that together with the SDR Play device on the roof, and you're good to go. You can operate it as if it would be connected locally through SDR Connect. So that's kind of the 3 evolution levels from inexpensive to more premium and luxurious.
Well, a lot of people are trying to get up there, including me, but I'm just getting the resistor icon, the wave icon in the beginning. So if you look at the comments, our friend Frank is trying, but it's not showing. So I don't know, maybe you're getting a lot of traffic and it's not letting it through.
Yeah, I'm seeing 4 connected users, so a few are getting in, 5.
Okay.
Maybe my firewalls, maybe you all clicked at the same time on the firewall said, hey, DDoS defense. I'll leave it up after the stream for a while. I think it's 7. I think it's 10 altogether anyway that can only access. I'm just gonna let it sit here after the stream for a while. And so if you don't get in now, just try again later. I might actually let it run all day, so I don't care. It's 8 people connected now, whoever the 8 lucky ones are.
This is just like entering our competition.
Yeah.
If you're lucky, you'll get in.
I think you guys cannot change the frequency, just in the band that I have. Yeah, just what I have open here. You can, but that's okay. You can check out the interface, see how that works, play with it. 7 connected. Well, that's kind of, I mean, that is just cool that you can have this thing installed wherever you want to. And technically, you guys could also install SDR Connect and use it as if it would be installed locally, not through a web interface. And this is really, it's a good selling point for me, especially the remote thing. The only thing that I would complain about is that it does not have PoE, no power over Ethernet, because that would be the ultimate bonus. But being an engineer, I wouldn't put PoE in it either. Too much dirty noise, and you would have to work with a switch mode, and inside a very sensitive receiver, I would stay miles away from it as well.
Well, that's great. Thanks for the demo. As you can see, there's a lot of interest. More people saying they can't get in. Peter said something very interesting here. In 1970, he worked on spark gap diathermy for bloodless surgery for the NHS. They were being removed from service for safety. Have you heard of that?
No.
First for me as well. Very interesting.
They put electrical current in tissue. What was it used for? For muscle and joint issues. So they're basically delivering the thermal remedy internally. That's interesting. No, never heard of it before. I had to Google it. But that's interesting.
Yeah, that is very
I'll
interesting.
remember that when my knees hurt again. I might give this a try.
Bloodless surgery. Yeah, for that, I would be more cautious to just experiment without any planning when it's your body.
True.
Nano VNA FV2 and Tiny SA Ultra are great tools. And
yes,
those
are the ones.
Sorry, carry on.
Those were the ones that I recommend. Nano VNA is one that I actually have myself. It's battery operated, great thing. The Tiny SA I haven't tried yet, but I've heard great things about it.
Awesome. Well, I've used more than an hour of your time, Sebastian. We could do 2 hours, but you know, it's been great that you haven't been here for a while, so there was so much to catch up on, and you really taught me a lot about that Raspberry Pi SDR V4. And there's a lot of interest in it, a lot of questions. So I'd like to say good luck to everyone who is entering. And unless there's anything further you want to drop in the video, we could wrap it up, Sebastian. Nothing further. So yeah,
I would definitely add we could fill 2 hours easily. We always can. So maybe we gotta, after the show, go ahead and schedule the next follow-on event.
Absolutely. We'll check out the calendar. Yes, Sebastian is always welcome here because it's always interesting and there's always lots of comments and people. Who would have thought radio is such an enthusiastic community in this day and age when we have fiber around the world and the internet giving us content all the time? But the radio enthusiasts keep going. Good on you guys. So thanks for joining us, Sebastian. I guess that wraps up EEI number 50. And a huge thank you to Sebastian for sharing his latest RF experiments and insights, spark gap transmitters, RTL, SDR. It's been very interesting. So if you enjoyed today's discussion, be sure to check out his work at baltic-lab.com or just look up Baltic Lab on YouTube. A lot of interesting stuff that we spoke about. He goes into far more depth there in his videos on his channel. And if you missed any part of this episode or want to revisit the conversation, the recording will be available on our YouTube channel at elector.tv, as well as on Sebastian's, because we simulcast today. And before I go, I just want to tell you about an upcoming webinar that we're doing on May 22nd. It is called Developing Matter-Based Energy Intelligence for the Autonomous Home. That'll be on May 22nd. And it explores the energy intelligent home by building on the matter foundation of interoperability. Should be interesting. So join us then May 22nd, same time, 4 p.m. in Europe. And pleasure, Wim. Thanking you, Sebastian and Brian. Once again, thanks for joining us. That was number 50 in the can, and we'll see you next time on our next Electro-Engineering Insights. And pleasure to Fabian, and goodbye, everyone. Good night, good morning, good afternoon, wherever you are. Cheers.
Tschüss.